All right, now let's look at our last question on the midterm, number 23. And this is about a hydraulic lift. And so what do we have here? We've got some fluid inside this container, and there's two pistons here. We can consider maybe these are cylindrical shaped containers for the fluid. Well, really just one container, it's all connected. And we've got these two pistons here. What does the piston do? It essentially seals the fluid inside, but it can move up or down. And so the idea with a hydraulic lift is if we can push down on this side, then this side is going to move up. But the hydraulic lift is an example of a simple machine in that the force that you get out may not be the same as the force you get in. And there's also that trade-off with the distance. That we can see certainly that if I push down here, I would have to push down quite a bit in order for this to rise up just a little bit because of the amount of fluid that has to be displaced here. Anyway, we really are going to use what's called Pascal's principle here. And that is that when we push down on this side, there's an increase in pressure in the fluid right below this piston. And the increase in pressure is going to be the force that we apply divided by the cross-sectional area of that cylindrical container there, the cross-sectional area of the piston. Actually, I'll tell you what, let's call this point 1 over here, and this point 2, look at those two pistons. And so we can say that there's an increase in pressure, that is the force 1 that we apply divided by that area 1. Now, Pascal's principle tells us that if we increase the pressure here by some amount, that we increase the pressure everywhere inside our fluid by the same amount. That means there's going to be an increase in pressure right below this piston with the same amount, but that increase in pressure, we should be able to write it as force 2, okay, the force that we get pushing up on this piston, the output force, divided by cross-sectional area 2. And at this point, I think we are given 3 out of those 4. Yes, we've got the 2 areas, cross-sectional areas. That would be area 2 and area 1. And we also have force 1 is the 50 newtons. And so just using a ratio here, 0.2 has, let's see here, 200 times the cross-sectional area. And so in order for this is 200 times bigger than this one, so for the ratio to be correct, this has to be 200 times bigger than this one. And so that will give us 10,000 newtons here. That's 200 times bigger than 50.